The Expedition 36 crew is getting set to execute the first space-based test of a system to permit control of a rover on the ground by a crew member on board an orbiting spacecraft. In this case, today, it'll be flight engineer Chris Cassidy controlling the activity of a rover called K-10 that you see here, which is located at NASA's Ames Research Center in Moffett Field, California. Someday, though, it might be an astronaut who's at the L2 Lagrange point running a robot on the moon. The investigation, called Surface Telerobotics, aims to find out how effectively a person on orbit can operate a robot on the ground. Earlier, I spoke with the payload developer, Maria Boilet, at Ames about today's operation and the background of this investigation. Well, let's start at the beginning. Where did this idea come from? Tell me why we think it would be a good idea for an astronaut in space to be able to control a robot down on a planet or a moon or an asteroid.
Well, I'm not sure exactly where the original idea comes from, but we've been working a lot on the human exploration architectures, at looking at ways that robotics can, what technologies are needed to enable those. And one of the hardest parts of any planetary mission is to safely land on the surface. And a robot on the surface controlled by crew, say in an orbiting or approaching vehicle, can get a lot of the sort of precursor exploration work done. A robot can be used, for example, to prepare a landing site, so they could scout for a clear area, make sure the ground is firm, or even perhaps build a landing strip.
But a robot couldn't do that all on pre-programmed instructions. It would need guidance.
Right, yes.
Now, most people are familiar with the idea of a remote control of a machine. I mean, kids have remote control planes and cars. But what are the problems that you're facing in this situation? What makes it hard for an astronaut in space to control the rover on the ground?
Well, first off, there's a communications delay between, say, station and robot on the ground. In the case of space station and here on Earth, it's a second or two, and it just makes it very difficult to joystick. That delay just adds to the amount of concentration that you need in order to control it. So we use something called supervisory control. So our robot's pretty smart. It can perform tasks, it can keep itself safe, and then the astronaut can take over if the rover runs into any trouble. So it doesn't quite know how to get around something, or isn't collecting the correct data. So we have the crew member monitoring what the robot's doing, and that's a little less of a direct control, and so the delay doesn't really interfere with that type of control. Another factor is the space environment. So, for example, the weightlessness, radiation exposure, stress factors, they can affect human performance and make it hard to understand the state of the robot. So our user interface is designed to make the rover state as clear as possible.
The crew member, what kind of feedback do they have? Is it just visual, or does the robot talk to them?
Yes, the robot sends telemetry, so it sends back information about its position, about its different subsystems. So, for example, what the battery level is, how the instruments are working, how it's pointed, and also imagery. So the rover uses stereo cameras in the front that give it information about obstacles that are in front, and so we can use that imagery to let the crew see what the rover is seeing. We also generate virtual terrain, so we show the robot in a virtual environment. That's the terrain data is created using those stereo cameras, and also a LiDAR that uses a laser to understand the three-dimensional terrain around the robot.
Is this interaction between them pretty well understood? Or are you expecting to get to learn something in this test that will let you refine it?
We want to see how a person in weightlessness in space reacts to this system. We've done a lot of work with it on the ground, but we've never done any kind of testing in space.
It sounds like you're testing Chris Cassidy more than you're testing your rover.
Not so much. I mean, we will be asking him questions. We'll say, something like, is the robot able to drive forward 1 meter? Will it encounter an obstacle? What's its battery level? And we're just trying to understand if he can get a good situational awareness from our interface. So in a way, we are testing him, but it's to give us an insight into how well our interfaces work.
In the case of this test, is there like a planned sequence of events, or is he just going to give it random commands?
We have a set of pre-planned sequences for the robot. So the robot has its mission. We are going to simulate deploying a radio telescope on the far side of the moon. And so, the idea is that we'll have had orbital data of the area we're interested in. And so ground teams will have created plans for the robot. And the idea is that when Chris sends the command to the robot and starts it executing, he'll just make sure that it's not encountering anything that it can't handle.
And how does he control it? Does he give it voice commands or joysticks or something like that?
No, it's a graphical user interface. So he'll see, as I mentioned, live images of the rover cameras, as well as there's a couple of 3D virtual views of the robot. The robot has several 3D sensors, so I mentioned the stereo cameras and the LiDAR, and then our system uses that information to create 3D virtual terrains, and then we have a model of the robot in that terrain, and that will display to Chris where the obstacles are, and he can use it to visualize what the robot is doing.
And he sends the commands in what way?
It's basically button presses. There's some preset commands. So, for example, drive 1 meter forward, rotate 15 degrees to the right, take another panorama. So, fairly simple commands.
And today's task is quite lengthy, in fact, right?
Yes, I believe we have a 2.5-hour block for operations. Before that, we'll be doing a little bit of training on the user interface.
At the end of the day, what is it that you hope to learn? What's going to be the next step in this development?
Well, we have 2 more crew sessions after this through the summer, so roughly 1 a month. So we'll continue testing, continue collecting data on the systems. We're not just going to look at how well the crew member can control the robot, but also some of our comm systems, what sorts of delays we're seeing. So we're also looking at some other technologies. And then after that, we're going to look at, analyze that data, see how well our systems work, where we can improve, and also where are the gaps in current technologies. So in other words, what new technologies do we need?
It sounds like it'll be fun and interesting to watch.
It should be. Robots are usually fun to watch since they're running around, and a lot of people tend to, relate to them.
Maria, really appreciate your taking the time for the update, and good luck with the tests.
Thank you very much.
Maria Boilat is the payload developer and project technical lead for the Surface Telerobotics investigation from NASA's Ames Research Center in California.